Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. So in this topic, I will explain about electromagnetic potential. Alright, so let's consider if we have one charge that distribute evenly inside a volume. So this particular charge is represented by rho v, which is volume charge density. So let's take one volume of charge, okay, inside this overall particle of charge, and direction of this volume of charge from the origin is given by this vector of Ri. Let's say we want to find, so what is the value for the potential difference, okay, caused by this charge at a position and direction that represented by this vector of R prime. So when we study on the topic of electrostatic, so basically the potential difference is given by this expression. So we will have 1 divided by 4 pi epsilon. Okay, so because we deal with rho v, okay, or the volume charge density, then we need to perform volume integration. So rho v vector of Ri divided by R prime. Whereas this vector of Ri is represent the position vector for the this volume of charge, and this R prime is represent the direction, so between the charge and the test point here. So if we have this charge density, so the value of the charge density is changed against time. So we will have, instead of we have rho v here, so we have rho v in the time. So because of that, so the potential difference that caused by this particular charge is given by this expression. So we will have v vector of Rt, so is equal to 1 divided by 4 pi epsilon. So volume integration of rho v R vector of Ri t divided by R prime dv. Alright, so if the value of charge, okay, is changed from, let's say, rho v1 until rho v2, so it will mean as well the value of potential difference will be changed from v1 until v2. So however, the changes of this potential difference is not immediately will happen. So it takes some delay time, and that particular delay time can be represented by this expression, whereas the delay time, or t prime, is equal to R prime divided. So whereas in this case, the UP is represent the velocity of propagation between charge and the observation point. If we consider this delay time, so basically the expression of our potential difference will be changed to this expression. So whereas we have v vector of Rt is equal to 1 divided by 4 pi epsilon. So volume integration of rho v vector of Ri, so this one will be represent the position vector for the our charge density, and the t minus R prime divided by UP, so this one will be represent the delay time here, so divided by R prime dv. So if we consider the potential difference that caused in a magnetic field, so we will have this expression. So we will use the same technique in order to derive it, and this is the product of that particular derivation. So we will have vector of A, which is represent the potential difference of a magnetic field. So R prime T, so is equal to mu divided by 4 pi volume integration of vector of J, vector of Ri, and then the delay time here, the T minus R prime divided by UP divided by R prime dv. And let's say if our rho v here, okay, so being expressed in a sinusoidal equation, so whereas we have rho v r vector of Ri t is equal to rho v Ri, so this one will be represent the position vector for this charge, and cos omega t plus phi, and unit of it is a coulomb per meter cubic. If we represent this expression, okay, so by using the phasor analysis, then we will have rho v vector of Ri T is equal to real value of rho v Ri exponential j omega t. And if we consider the same expression for the delay time, so we will have the expression for this charge is given by this formula, whereas we have real value for Rv, vector of Ri exponential j omega, so t minus r prime divided by up. And this exponential can be rewrite as this one. So we will have this real value of rho v, the vector of Ri exponential minus j kr prime exponential j omega t. So we can separate that particular exponential expression. So whereas in this case we introduce another constant here, so we have constant of k is equal to omega divided by up, and this omega is represent the frequency. So we have that the vector for the expression for the potential is given by real value Vr e power of exponential j omega t, and this as well will be equal to real value of 1 divided by 4 pi volume integration of rho v vector of Ri exponential minus j kr prime exponential j omega t divided by r prime dt. And if we consider this both equation, then we can cancel out this expression. Then in the end, so we will have the expression for the vector potential. If we consider this rho v is in a sinusoidal equation, so we will have v vector of r is equal to 1 divided by 4 pi epsilon volume integration of rho v vector of Ri exponential minus j kr, so divided by r prime dv. Okay, so same goes to the magnetic field. Okay, if we have the current density of that used to induce magnetic field in a function of sinusoidal, so we will have the expression for the vector potential for the magnetic field is equal to mu divided by 4 pi volume integration, so vector of j with a function of a vector of Ri exponential minus j kr, so divided by r prime dv. Alright, so that's all for now. So should you have any questions, so please do not hesitate to submit to me. So thank you, good luck, and have a nice day.